Hello everyone, welcome to MBA Karo. So today is the last video of this series Hot Summer, and I'm quite sure that you must have enjoyed this series thus far. And in today's video we are going to solve questions on modern math. It is one of the topics which is lesser asked, although there are a lot of variety of questions. We will cover different varieties of questions in this video. However, it has less weight in CAT, but it is equally good for examinations like NMAT and SNAP, wherein you definitely get questions from it. In fact, in NMAT you get 4 to 5 questions, and even in SNAP you can expect 2 to 3 questions from this topic. So modern math probably will cover permutation, combination and probability. If you are new to the channel, please don't forget to subscribe to the channel and follow us on social media platforms. This was the schedule, so in case you are yet to watch the previous videos, you can look at the schedule and watch all these 30 videos, and this will definitely give you a boost for all MBA entrance examinations. And in case you wish to enroll in our CAT 2024 batch, you can do so, wherein you will get structured preparation, topic wise practice sheets, doubt resolution, full length and sectional tests, as well as GDPI preparation. So try to solve the questions on your own and then look at the solutions. So let's begin with the first question. Now this is a question which is based on dictionary arrangement of words. So it says the letters of the word Rachit are arranged in all possible ways as listed in the dictionary. What is the rank of the word Rachit? So if you look at the dictionary, first of all words from A will start. Okay. So when you have words starting from A, the remaining letters are R, C, H, I, T. So these are 5 different letters. So they can be arranged in 5 factorial ways, that is 120 ways. Now the next letter is A. Now the words will start from A. So we have the remaining letters as R, A, H, I, T. Now again we can arrange these in 5 factorial ways because all 5 are different letters. So 120 ways of arranging this. Next is H, and similarly we have I also. So we have 120 ways for these and these. Now when we come to R, like we have used A, C, H, I, next letter will be R. The first word that we will get is R, A. Then after A the next letter is C. Then after C the next letter is H. Then the next letter is I, and then is T. So this is the first word after this. So what is the rank of this word? So we have 120, 120, 120, 480 plus 1. The rank is going to be 481. So we found out the number of words using each of the different letters, and when we start with R, the very first word is Rachit. So we will get the answer as 481. A paper has 2 sections, section 1 and section 2, each containing 6 questions. A candidate is required to answer 7 questions out of the 12 questions. She is not permitted to attempt more than 5 questions from either group. Find the number of different ways of doing questions. Okay, so a candidate has to attempt some questions out of the given questions subject to certain conditions. Okay, so let's look at in how many ways can the candidate answer the question. So in section 1 there are 6 questions, and it should be not more than 5 questions from either group. Okay, so section 1, a person can attempt, so total it has to be 6 questions. So minimum, like a person should attempt 1 question from a section and another from this. So 1 question from this section and 5 from this section. Okay, because maximum 5 are allowed from this. Sorry, there are total 7, so it will be 2 and 5. Right, total is 7. So 7 can be 2 plus 5. Maximum we can attempt 5 in this. So it can be 3, 4. Okay, then it can be 4, 3, or it can be 5, 2. Okay, So if a student attempts 2 questions out of 6, see, we do not have to arrange. So basically we have to select 2 questions. So it will be 6C2, this will be 6C3, this will be 6C4, and this is 6C5, and this will be 6C5, 6C4 and 6C2. So 6C2 is basically 6 into 5 by 2, which is 15. Okay, 6C3 is this is 20. 6C4 will be equal to this, and 6C5 equals to 6, right? So first case, case 1, we will have 15 into 6C5 is 6 ways. Second case, 6C3 is 20, and this is 6C4, which is 15. Next case is 15 into 20, and the last case is 6, and 6C2 is 15. So we have 90 ways to select, 300, and again 90 ways. So there are a total of 780 ways to attempt the questions. So we need to select the number of questions, and this is the number that we will get in these cases. Okay, so let's look at the next question. It says, using the digits 1, 2, 3, 4, 5 and 6 and 7, a 4-digit number is formed and it has 4 different digits. You need to find how many numbers are exactly divisible by 25. Okay, now this is comparatively easy, because divisible by 25 means what? So divisible by 25 means the last 2 digits are either 0, 0, 2, 5, 5, 0 or 7, 5. Now 0 is not mentioned in this, so we will rule out these 2 possibilities. So basically the last 2 digits are 2, 5 or 7, 5. Okay, now let's take the last 2 digits are 2, 5 and the last 2 digits are 7, 5. Okay, so if last 2 digits are 2, 5, then we should have 4 different digits. Okay, so 2 and 5 have been selected. 1, 2, 3, 4, 5. 5 ways to select this digit. There are 5 ways to select this digit. Okay, and now 3 digits are selected. We have 4 ways to select this digit. So we have 20 ways. Similarly, here we have 5 ways to select this digit, because 7 and 5 are selected. So 7 and 5 selected. We have 1, 2, 3, 4, 5 choices. So 5 choices for this digit and 4 choices for this digit. So total 20 ways of selecting. So 20 plus 20, we get 40 ways in which the number can be divisible by 25. In how many ways can a cricket team of 11 players be selected from 16 players such that it includes 2 particular players, Smriti and Harmanpreet? Okay, now this is a selection based question in which we are given some condition. So we need to adhere to that condition. So it says that there are 11 players to be selected, and out of 16, and 2 players have to be included. Now when we have inclusion, so these 2 players are already included, right? It has to include, so that means we essentially have to select only 9 players, and out of 14 players, because these 2 are already in, so we have to have 9 players out of 14. So the number of selections is 14C9. That is 14, 13, 12, 10 upon C, 14 factorial by 9 factorial into 5 factorial. Okay, so 9 factorial means 9 and beyond are removed, because that is 9 factorial. Okay, and in the denominator 9 factorial will get removed. So this is into 5 factorial, that is 5 into 4 into 3 into 2 into 1. Okay, so 5 into 2 is 10, gets removed. 4 into 3 is 12, that gets removed. So we have 14 into 13 into 11. Okay, now if you look at this, the last digit is 2, hence the number is going to be 2002. So that is the number of ways of selection. So whenever we have selective selection, like we are given that 2 people are already selected, now we are remaining with 14 players and we have to select 9 out of them. Similarly, if it said that these 2 players have to be excluded, suppose the question was it should not include. So in that, what we will do, we are left with 14 players and we have to select 11 players out of it. Okay, so if that was the case, in that case we will find 14C11. So we need to say that which are included, which are not included. How many words can be formed using the letters of the word intermediate such that the vowels and consonants appear at alternate positions? So first of all, we will have to find the vowels and consonants and try to arrange them in alternate positions. Okay, so if we look at the vowels and consonants, so this is 1 vowel, 2 vowel, 3, 4, 5, 6. So I, E, I, A, E. These are 6 vowels. Okay, and then we have Ed, R, M, D, T. These are 6 consonants. Okay, now they should appear at alternate positions. So first of all, we will make 2 cases, right? First case is we have vowel consonant and so on. So these are 12 letters like this, or we can have consonant vowel like this. We have 12 cases. So basically we will multiply the result by 2 because the internal pattern will remain the same. Okay, so the internal pattern, I mean that the number of ways of arrangement in both the cases will be same. So we shall multiply by 2 to get the final answer. Okay, now if we look at this, so we have 2 portions. One portion consonants. Okay, now consonants are arranged in how many ways? Vowels are arranged in how many ways? 1, 2, 3, 4, 5, 6. We have 6 vowels. Out of them we have E coming 3 times, okay, and I coming 2 times. So this is the arrangement of vowels. Of consonants, we have 1, 2, 3, 4, 5, 6 consonants, and among themselves we have T repeating twice. So this is the number of arrangements, and we saw that we can have 2 arrangements like vowel and consonants and consonant and vowels. So we will multiply by 2 because these are arrangement of vowels, these are arrangement of consonants, and they can be arranged in among themselves in 2 ways. Okay, so 2 will get cancelled out. We will have 6 factorial is 720. This is also 720, and this is 6 into 2, right? So we will get 12, that is 60, and 720. So that will be double zeros. 72 into 6 will get 43,200 ways. Okay, so what we do is we make bundles. So we are given 2 bundles and do arrangement within the bundles. So in one bundle, since there are 6 elements, it will be 6 factorial divided by the number of repetitions. So if an element is repeating 3 times, we will divide by 3 factorial. If an element is repeating twice, so we will divide by 2 factorial. So that is the answer. There are 10 distinct books in a shelf of a library. In how many ways can a student pick 4 books such that he does not pick 2 consecutive books? Okay. Now this is, the previous question was on bundling. This is a question on separation. Okay. So the person should not pick 2 consecutive books. Okay, and he has to pick 4 out of 10. So first of all, we will make 1, 2, 3, 4. So he has to pick 4 books. So non-picking is 6 books. 1, 2, 3, 4, 5, 6. Right? He should not pick 6 books. 1, 2, 3, 4, 5, 6. Now he has to pick 4 books. So let us place these 6 books, and then we can place 4 books at 1, 2, 3, 4, 5, 6, 7. So these are books that he will not pick, and then he can pick any 4 books. Like we will separate, there are 10, we should not pick 6 books. So first place 6 books that should not be picked. Now we will pick that, we will put the books that have to be picked in these gaps. So how many gaps do we have? We have 7 gaps, okay, and in the 7 we can put books in any 4 of them, right? We can have 1 book here, 1 book here, 1 book here, 1 book here, or we can have 1 book here, 2nd book, 3rd book, 4th book. So we can put books, 4 books in any of these 7 gaps. And see, it is just a selection based question, so the answer will be 7C4. 7C4 is 765 upon 6, which is 35. So we have 35 ways in which a person can pick 4 books such that no 2 books are consecutive, and that means next to each other. I hope you are enjoying this session, so please do like this video, and let's solve some more questions on this. In how many ways can 5 boys and 3 girls be seated in a row such that all girls do not sit together? Okay, so one needs to be careful. It is how it is different from the previous question that we just did. Okay, so what we did was, like, we separated those books. Now there are 5 boys and 3 girls. The girls should not sit together. Now one needs to understand that there is one way wherein, let's say, 3 girls are there. Okay, so one way is that 3 girls are together, and boys can be arranged anywhere, like in between the boys. Another thing is 2 girls are together and 1 girl is separate, okay, and the boys are arranged anywhere, like randomly. Okay, and the third case is all 3 girls are separate. Okay, so let's understand these 3 cases, right? So one possibility is all 3 girls are together, another possibility is 2 girls are together, 1 girl is separate, and the third possibility is all 3 girls are separate. Now this thing can be done by the way which we did in the previous question, that we will arrange 5 boys and put girls into 3 of these slots. Okay, this we can put girls together and girls will make a bundle and arrange the ways, right? Now we need to tell that the girls do not sit together. All the girls do not sit together. So basically we have to count these 2 cases. All girls should not be together, right? So we will find all cases minus this case. Okay. So first of all arrangement is there are 8 people, 5 boys and 3 girls, so that is 8 factorial, which is 40,320. Okay, so what I would suggest that have knowledge of factorials up to 8. That is going to be handy for you. If not 8, at least till 7, or even if you have till 6, you can multiply and calculate. Okay, so all arrangement is, total arrangements is this. Now what we need to do is, we need to, like, once we will find all girls together and then we will separate them. So if all girls are together, let us say this is one bundle. Okay, now we have boys, 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 so we will make a single bundle. Now how many elements are there? There are 1, 2, 3, 4, 5, 6 elements, so they can be arranged in 6 factorial ways. 6 things can be arranged in 6 factorial ways, and the girls are together, they can be arranged among themselves in 3 factorial ways. So 6 factorial ways is basically 720. and this is 6, so which is 4320. So we will get 4320 ways in which the girls are all girls together. Okay, so we need to subtract this case from total. So if you see, this is 320, that is 0, and the answer will be 36,000. So there are 36,000 arrangements such that like all girls are not together. Okay, so this is how we solve this. So we will, instead of adding these two cases, because this is a complicated case to make, we will have to make different combinations in this. This is easy to make because we will place first 5 boys together and then place girls in between. This is difficult and this is also easy to make. So we will do is, we will find total arrangements and subtract all girls together from it. At a cabinet meeting, everyone shook hands once with everyone else. Halfway through the meeting, the Prime Minister arrived and shook hands only with a few people. In all, there were 240 handshakes. With how many people did the Prime Minister shake hands? Okay, so now this is a problem of handshake. Now what happens in a handshake is, if 2 people are present, okay, so if there are 2 people, there will be 1 handshake. Okay, so basically handshake is selection of 2 people. So if there are 10 people, you select 2 people, so any 2 people selected will have 1 handshake. So number of handshakes is equal to NC2, which is n minus 1 upon 2, right? Now like the people, everyone shook hands with once and some people shook hands with the Prime Minister. Okay, so NC2, or you can say n minus 1 by 2 should be less than 240 because the actual number of handshakes is less than 240. So we get n minus 1 is less than 480. Now by hit and trial, let us think of some number. 22 square is 484. Okay, so if you put 22 here and 21 here, this is less than 480. If we take 23 and 22, this will be greater than 480. So we are not going to accept this number. Okay, so that means n is 22. If n is 22, then the number of handshakes will be 22 into 21 by 2, which is 231. Now 231 handshakes are among the people present in that meeting. 231 handshakes among the people present in the meeting. Some people shook hands with the Prime Minister. So there are total 240 handshakes and 231 handshakes among the members who are present. So that means the Prime Minister shook hands with 9 persons. Okay, so the concept of handshakes is NC2, selection of 2 people out of the given n people. In a Euro-American football competition involving American teams and some European teams, every team had to play exactly 1 game with every other team. It was found that in 36 games, both the teams were European teams, and in 15 games, both were American teams. The number of games in which one team was an American team and the other was a European team is. Okay, so we need to answer this question, that how many games were there in which one team was American and the other was European. Okay, so let's say there were X games in which X, you could say X American teams. Suppose there American teams are X and European teams are Y. Okay, now it is said that like American will happen wherein we select 2 American teams, so XC2, right, selecting if there is a match between both, or like both American teams, it says there are 15 games which had both American teams. So XC2 is 15. Similarly, both European teams means YC2, which is 36. So basically, if both American teams are playing, okay, so we are selecting 2 American teams out of the given group of teams, and both like European teams means we are selecting 2 teams out of the entire pool of European teams. So XC2 means x minus 1 by 2, which is 15. So x minus 1 is 30. So x is 6. Similarly, y minus 1 by 2 is equal to 36. So y minus 1 is 72, y is 9. Okay, so that means there are 6 American teams and 9 European teams. Okay, now the question is, how many matches had an American team and another is European team? So 6 American teams and 9 European teams. So the number of matches will be 6 into 9, because 1 American team will play with 9 European teams. So 6 American teams will play with 6 into 9, 54 teams. So it will be 54 such matches wherein like 1 American team was there and the other was a European team. The number of ways in which we can choose a committee from 4 men and 6 women, so that the committee includes at least 2 men and exactly twice as many women as men are. So we need to do a selection here, right? There are some men and some women, and we have to select at least 2 men and exactly twice as many women. So let's find out in how many ways can we select this committee. So when we have, like, we have to select at least 2 men. So one possibility is we select 2 men and 4 women, twice as many men. So 2 men, 4 women. Another possibility is we select 3 men and 6 women. Okay, we cannot select 4 men, or we cannot select less than that. Okay, so there are 2 possibilities. Now 2 men means there are 4 men, so 4C2, and 6 women, so 6C4. Similarly, 4C3 and into 6C6. So 4C2 is 6, 4 into 3 by 2. So NC2 is, remember this rule, n minus 1 by 2. NC3 is n minus 2 by 6. Okay, so 6C4 is 6C2, which is 15, 6 into 5 by 2. 4C3 is 4C1, that is 4, and 6C6 is 1. So we have 90 ways of selecting this and 4 ways of selecting this. So we have a total of 94 ways of selecting the team. Okay. Now this is something which is often asked in the examination, the number of positive integral solutions. Okay. Now see, one thing you need to know is, like, if we are asked, there are 2 things. One is non-negative and one is positive, right? I'll tell you both. So suppose non-negative means, if the question was non-negative means 0 is also included. Okay, so you can get questions on these non-negative or positive integer solutions. So how do we find non-negative solutions? So I am not explaining you that how we do it, the derivation. Okay, derivation is also simple. I mean, you can check for it, that the derivation for like how to find non-negative integer solutions, you will find the derivation also. I'll tell you the direct way to result. So if we have to find, let's say a plus b plus c plus d is 11. Okay, so what we will do is, we will put, like, how many partitions are there? 1, 2, 3, 4. So it is 7. So what we will do, 7 plus 4, C4. Okay, so that will be the number of non-negative solutions. So that will be 11 C4, So that will be 11 into 10 into 9 into 8 upon 24, 3 times, so it is 330. But the question is asking about positive integer solutions. Okay, positive integer solution. So what we will do, we will assign, there is a plus b plus c plus d plus e. We will assign 1 1 1 to each. Total is 7. So we are left with, so like we will assign 1 1 1 and subtract this from here. So now we have to find a plus b plus c plus d plus e is equal to how much? 2. So it is easy to find non-negative, and for positive or any higher value, they will give you that minimum value of a is 1 or anything, so you can put it accordingly. So now what we did is we assigned 1 1 to each of the variables, and then we get this equation. Now see, there is 2, so how many partitions are there? 1 2 3 4. So 4 plus 2, or you can say 2 4 4 c 4. Okay, so this value plus number of partitions, c number of partitions, so this is 6 c 4. So we have 15 such solutions. Okay, so this is how we solve non-negative and also positive integer solutions. Okay, now let's look at the next question. It says, in how many ways can 27 sweets be distributed among 3 children such that each child gets an odd number of sweets? Okay, now each child should get an odd number of sweets. So 3 children. So what is an odd number? Odd number is 2a plus 1. Odd number is 2b plus 1. 2c plus 1. Okay, that is equal to 27. Okay, now here a can take values like 0 1 2 3 4 etc. Okay, because even if a is 0, we get 1 as the number. Okay, we will get 1 as the number. If we put a equal to 0, then this quantity is 1, right? So a 0 is permissible. So basically we have to find what we did here, non-negative solutions. Okay, we have to find non-negative solutions of this equation. Now let's do the next step, right? We will solve like it gives 2a plus 2b plus 2c is equal to 24, or we get a plus b plus c equals to 12. And what we need to find? We need to find non-negative solutions. And what is non-negative solution? Non-negative solution is, see, we have 2 partitions here, so we will put 14, 12 plus 2, okay, 12 plus 2, c 2. So 14 c2, that is 14 into 30 by 2, 7 into 30, we have 91 ways of distribution. Okay, so I hope you got how to find non-negative solutions and positive integer solutions. So non-negative is very simple. You just need to find how many terms we are adding. Okay, so if like we are adding 5 terms, so we have 4 partitions. So given the sum here, s plus 4 c 4. Okay, so likewise here we have sum is 12, so 12 plus 2 is 14, 14 c 2. That's how we get the answer. You can check out for the video on this, that how it is derived, how to find the non-negative solutions. Okay, now let's move on to the next question. So please like this video if you are finding this session useful. How many ways can 4 men and 4 women be seated at a round table if they have to alternate the men and women? Okay, now what happens in like circular arrangement? This is a question based on circular arrangement. So circular arrangement, if there is an empty table, right? If there is a linear arrangement, we have n factorial ways. If there is a circular table, we have n minus 1 factorial ways. Okay, now when there are 4 men, so we can arrange 4 men in 3 factorial ways. Okay, so 4 men can be placed in 3 factorial ways. Now we need to place 4 women. Now the positions are now fixed. So this happens only when there is an empty table, because we can rotate the table. Now these people are already placed, we need to place 4 women. So there are 4 seats and we have to place 4 women. So that is 4 factorial ways. 6 into 24, it is 144. So there are 144 ways of placing these people around a circular table. Okay, so if only men had to be arranged, let's say there were 6 people, so we would say 5 factorial ways if it is an empty table. But once people are arranged, then we need to arrange the remaining people accordingly. A nursery kid has 5 notebooks to give out to her 5 classmates. Determine the number of ways such that at least one student gets their name tag. Okay. Now this is a topic called derangement. Okay, derangement means none of them gets the right tag. So a kid has 5 notebooks to give. So in how many ways? Total ways of giving. Is 5 factorial, which is 120. Okay. Determine the number of ways such that at least one student gets their name tag. Okay. So all incorrect, you can say that distribution, that is called derangement. So if you distribute certain things that all of them are incorrectly distributed, that is called derangement. Okay. So for derangement we have a formula, like we say that it is n factorial upon 1 minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial and so on up to n factorial. Okay. So for 5 items it is 5 factorial 1 minus 1 plus, or we can put it inside itself, so we will get 1 by 2 minus 1 by 6 plus 1 by 24 minus 1 by 120. Okay, so this gets cancelled. Now this is 5 factorial by 2. 5 factorial is 120. 120 by 2 is 60 minus 20. This is 5. 5 factorial is 120. 120 by 24 is 5 and minus 1. So that is 44. So all incorrect distribution is 44. So there are 120 ways of distributing, in which in 44 cases the notebooks will go to wrong people. So there are 76 ways in which at least one student will get the correct name tag. Okay, so these derangement based questions, again like permutation combination is quite vast, and if you wish to study in detail, then study from a proper source, because like study from a proper book and a proper source, because there are a lot of topics and you never know that in an examination what might be tested. And however in CAT there are few questions asked, but if you have covered everything in detail, like if you are covering the syllabus holistically, I would request you to cover all the varieties, at least know the basics. If not practicing too much of it, at least know the basics, so that if any kind of question comes up in the examination, you are able to solve it. Alright, so now let's solve some questions on probability. This question says a bag contains 7 red balls, 4 green balls and 5 yellow balls. What is the probability that 3 balls at random are either green or yellow? Okay, so we should get either green or yellow, so we should not get red ball. Okay, so we need to pick what is the probability. Probability is favorable upon total outcomes. So what is a favorable outcome? That means we need to get green or yellow. So there are 4 greens and 5 yellow balls. So that means we have to pick 3 balls out of 9 of these balls. And total outcomes are, we have 16 balls and we need to pick 3 balls out of these 16. So if you are able to pick 3 balls out of 16, that is the total probability. So 987 upon like see 9C3 will be 987 upon 3 factorial, and this is 16C3 16 15 14 by 3 factorial. So since the denominator is same, we can remove it. So it is 987 by 16 15 and 14. 8 into 2 is 16, 3 into 5, 3 and 5, and this is twice. So we get 3 upon 16C3 16 15 14 so it turns out to be, this is 2 times 3 by 5 and this is 2. So this is coming as 3 by 20, which is not among the options. So these are 2 times, and this is twice, and this is 3 by 5. So the answer should be 3 by 20, which is not present in the option. Please check that if it is 3 by 20 only, right? So we have to pick 3 out of 9, and the total balls are 16. So we have to pick 16. The total arrangement says, total ways of selection is 16C3. A box contains 12 cards with numbers 1 to 12 consecutive numbers. If we take 5 cards at random without replacement from this box, what is the probability that the median of the numbers selected is 5? Now median number means the central number. Okay, so central number is 5. That means we have to pick 5. Right? The first and foremost thing is we have to pick 5. Then only the median will be 5. Now we have 4 numbers here, 1 2 3 4, and then we have 6 7 8 9 10 11 12. Now this is the median number, and we are taking 5 cards, so that means it is the third number in ascending or descending order. So if it is a third number, there should be 2 numbers before it, so we need to pick 2 numbers out of this, and we need to pick 2 numbers out of this. Okay, so in how many ways can we pick 2 numbers out of this? 4C2. This is the favorable ways of picking 4C2. 2 numbers out of these 4, and 1 2 3 4 5 6 7. So we have to pick 2 numbers out of these 7. So 2 numbers from this and 2 numbers from this, and upon the total ways of selection. So this is the favorable outcome, that we are picking 5 as the third number, and 2 numbers from the first 4 and 2 numbers from the last 7. And what is the total number of ways of picking? We are picking 5 numbers out of 12 given numbers. Okay, so we will get 4 into 3 by 2 and into 7 into 6 by 2, and 12 factorial is basically 12 into 11 into 10 into 9 into 8 into, this is 5 factorial, so this is 120. Okay, so a bit of calculation is needed. 120 will go away with these 2, right? Then we have 2 will eliminate 4, then 3 and 6 is 18, so 9 into 2 is 18, and 2 will take care of this 8 4. So it becomes 7 by 44. So the answer is 7 by 44. So median means the central number should be 5. So 2 numbers should be less than 5, and the other 2 numbers should be more than 5. And this is the way of selection. There are 2 brothers A and B. the probability that A will pass in the examination is 3 by 5 and B will pass in the examination is 5 by 8, what will be the probability that only one will pass the examination? Now this is conditional probability, wherein one of them will pass, another will fail. So we will take the cases wherein there are three. Now in this kind of questions you might be presented three cases. One is neither, so let's take all these things. One is neither pass, okay, one is neither, one is both, and third is one of them passes. So neither pass means like A and B, the probability of passing of A is 3 by 5, so failing of A is 2 by 5. B passes is 5 by 8, so B failing is 3 by 8. Okay. Now neither passes will be A fail into B fail. Okay, the probability of will multiply this, so 2 by 5 into 3 by 8. Okay, which is 6 by 40 or 3 by 20. Okay, if you have to find both pass, so both passing is A pass into B pass, so that is equal to 3 by 5 into 5 by 8, which is 5 get cancelled, that is 3 by 8, right? Now only one pass, so there are two ways to calculate it. One way is, since these two are easy to calculate, 1 minus neither minus both, so it is 1 minus 3 by 20 minus 3 by 8, which is 40. So 40 minus 6 minus 15 by 40, so that is 21 by 40. Okay, one way is to achieve like this, 1 minus neither minus both. Other way that we are going to do is A pass into B fail, and another scenario is A fails and B passes. So let's find these probabilities. A pass is 3 by 5 and B fail is 3 by 8. Second case is A fails, which is 2 by 5, and B passes, which is 5 by 8. Okay, so A fails and B passes. So this is 19 by 40. 21 we will subtract, so will be 19 by 40. So this case 9 by 40 and 10 by 40. So we will get 19 by 40. So you can use either ways to calculate it. Right, you can either find this way, or you can find these two and subtract from total. So in either case you will get the answer as 19 by 40. So either you multiply A pass and B fail plus B pass and A fail, or you find both pass, both fail and subtract from 1, so that you get only one of them will pass the exam. Okay. Now next is, a man is known to speak truth 2 out of 3 times. He throws a die and reports that number obtained is a 4. Find the probability that the number obtained is actually a 4. Now this is a question from Bayes theorem, and if you study Bayes theorem from books, it is very difficult, and you will not be able to understand the language. So try understanding Bayes theorem from a book. Just Google it, like you can read from any of the books, or if you pick any of the books on probability and try to understand it, you will never understand it. It's quite difficult to understand. Okay, but try to understand what Bayes theorem means. Bayes theorem is, one event has already happened. What is the event that has happened here? The person has reported 4. Okay, so now how to find the probability in this cases? So we need to find the number is actually a 4. Okay, so we need to find P, number is 4. Okay, and he is speaking truth upon probability that he reports a 4, right? This has already happened. He has reported a 4. So we need to find the number is 4 and he is speaking the truth. Okay, so we will do it in the the formula way, plus we will draw the tree diagram also. So try to understand using either of these, you should be able to understand it. And like if you go by that formula PA/B, that is difficult to understand the bookish way. So number is 4 and truth. So 4 and truth, what is the probability of 4 and truth upon P reporting of 4? So that means is P 4 and truth. Now he reports a 4, that could be two possibilities. So it is 4 and truth, or it could be like you would say plus probability of not 4 and false. So there are two ways, like he is reporting 4, so that is possible that it is actually a 4 and he is telling the truth, and it is also possible that it is not a 4 but he is telling a lie. Okay, so 4 and truth is how much? Probability of getting a 4 is 1/6, and the person speaking a truth is 2/3. Upon first case will remain this only, second case is not a 4, so 5/6 is not a 4 and he speaks false in 1/3 ways. So we will get 2/18 upon 2/18 plus 5/18. So basically 2/18 by 7/18. Since the denominator is same, we will get the probability as 2/7. So one way is this. Another way is using a tree diagram for the same thing. So we will have like we can have 4 in two ways, right? Like if we talk about like 4, so it can be so we have to find the probability such that he is like speaking the truth and also at the time. So let's make a table like this, truth and lie. Okay. Truth is how much times? 2/3 times, and lie is 1/3 times. Okay. Now in this like he can speak truth or he can speak lie also. Now when he is speaking truth, it can be 4, it can be not 4. When he is telling a lie, it can be 4, it may be not 4. Okay. So now it is a 4. What is the probability of getting a 4? 1/6, and not 4 is 5/6. Similarly, here also number of 4 is 1/6 and it is 5/6. Now what we need to find? We need to multiply, like in how many ways can he be like which all cases we will be picking. So we will pick the case where he is speaking the truth and it is 1/6. Okay, he is speaking the truth and it is 4, right? Now another way is he can tell 4 when he is like he is telling a lie and it is not 1/4, because if he is telling lie and it is 4, then it is not, like he will not tell it is a 4. So if he is telling a lie and it is not 4, he can tell that it is a 4. So this is our case. So the denominator will be this, that's what we calculated, 1/6 into 2/3 and 5/6 into 1/3. He is telling a lie and the number is not 4. Now favorable case is this one, right? It is actually a 4. So actually a 4 means this is the case that we will consider. So this becomes our numerator and denominator is this case, that is actually a 4, and the second case could be it is not a 4 but he is telling a lie. So those two cases we can put here and then add. So this is what is called Bayes theorem. Okay, and if you go by the bookish language, it is difficult to solve Bayes theorem questions, but this is how you can draw a tree diagram, or you can use a table directly and calculate the values. In case you are preparing for CAT and other MBA entrance tests, so we have launched our test series for different examinations, and for CAT the mocks will be released soon. The free mock is already live, and for other MBA entrance tests, for now we have NMAT mocks, and as soon as the examinations are announced, we shall keep launching the mocks for these examinations. based on the latest pattern. So this series was a huge hit, and a lot of students asked to enroll in our CAT course, but they wanted a fresh course. So we will be launching a crash course probably somewhere around September. Okay, and like if you wish to enroll in our current course, you can do so, because it's a comprehensive course. It's right from the scratch, and as you can see, today we just did modern math, which was like in which we just solved the questions. We did not understand the concepts in depth. However, in the classes we have all these concepts being taught right from the basics. So in fact, in modern math we'll have multiple classes, so 4 classes on permutation combination, where we will teach each of the varieties. And not only just that, all the topics are taught from the scratch. And if you wish to enroll in that course, you can do so by checking out the link given in the description. And we will be launching a crash course in September to cater to those students who have already covered the basics on their own and want to study, to revise for the examination and solve good quality questions, so that they ace the examination. So please do subscribe to our channel and follow us on social media platforms, so that you do not miss out the notification of this batch announcement. So wait for a few months. Until then, please do watch the videos on our platform, on our YouTube channel. You can see a lot of videos from the past also, catering to different MBA entrance examinations. So you can watch those videos, you can watch marathon sessions, etc. That will like help you a lot, and you will understand that how to solve questions in very interesting formats. So there are some questions for you to answer in the comments of this video. Try to solve these questions and answer in the comments of this video. So this was a series which if you watched completely right from the first video till this 30th video, definitely it would have benefited you a lot. If you want to get the PDFs of these classes, please join our Telegram group, where we post all these PDFs. So this brings us to the end of this wonderful series, and I am sure that you enjoyed watching these classes, and they must have given you a lot of conceptual clarity and also taught you interesting ways of solving problems in all the 3 sections, that what to focus on, what not to focus on, how to tackle problems. So if you found this series useful, please do recommend it to your fellow aspirants. Do let them know about our content and how it is different from other institutes, the quality of the content. And please do subscribe to our channel for more upcoming content on different MBA entrance examinations, and don't forget to like this video if you enjoyed it. So thanks for watching this video. Have a great day. Goodbye.